So concept we need to talk about with reactions of alcohols are the elimination reactions. And there are two types, E1 and E2. Now, go back to the thoughts you had about Sn1, Sn2. We had an Sn1 reaction, our leaving group popped off first, we formed a carbocation, and then we completed the reaction with the attacking nucleophile. For the Sn2, the attacking nucleophile and the leaving group moved at the same time. So one kind of pushed the other one off. This is going to be the same thing with the E1, E2 mechanism. So when we say E, we are saying elimination. We're taking the alcohol and we are dehydrating the alkane to form an alkene. So for the E1 mechanism, we're going to go through a carbon-cation intermediate. So typically this is an acid-catalyzed reaction. We have an H plus floating around in solution. The alcohol is going to form a bond with the H plus to form an OH2 transition state. The OH2 transition state pops off, and we're going to end up with a carbocation. So, comments about this. Depending on what R1, R2 are will dictate the stability of this carbocation. So, if R1 and R2 are both alkyl groups, this is going to be much more stabilized than if R1 and R2 are hydrogens. This is why you don't typically see E1 when you start seeing primary alcohol. So we typically need a secondary or tertiary alcohol to make this happen. Now we do have a carbocation so this means that we could also get some types of rearrangements as well. And this can explain why we start seeing rearrangements with secondary alcohols. Next step, another water molecule is going to come in, extract our hydrogen. This is going to come down, form a bond, and we've created our alkene. So the second transition state here is that deprotonation from the neighboring carbon. Now we're going to follow Zaitsev's rule. When we do eliminations, we're typically going to favor hydrogen elimination for more substituted carbons. And this is our end result. How about an E2 mechanism? Well, for an E2 mechanism, we're kind of relying on a concerted motion. So, gets a bit more complicated what's going on, but what we're going to do is we're going to attack the H here. H is going to form a bond. We're going to see the bond kick back up to the water. And in one fell swoop, we're going to take it and we're going to create this double bond. So the E2 mechanism is used to explain dehydration of primary alcohol. So if you have something like ethanol and you want to make that to ethylene, it can be done, but it's not going to go through an E1 mechanism because you would form a primary carbocation. In that case, to dehydrate something like ethanol, C2H5OH, you kind of have to do this through a concerted process, which explains why it's a slower process. So these are our two mechanisms for elimination. E1, we form a carbocation first, then we deprotonate the alkane to give us an alkene. And the E2 mechanism, this deprotonation step and this OH minus, this OH removal, the alcohol removal, are all done in one step.